Okay, so our final strategy is perfect squares. And similarly to difference of squares, there's a structure to perfect squares. All right, so what is a perfect square? Let's kind of fix that question first. So a x squared plus 6x plus 9 can be considered a perfect square. And that's because if we factor this by inspection, we will notice that our factors are identical twins. X plus 3 times x plus 3. And if I have two identical products, I can rewrite that as a perfect square. Okay, so a perfect square trinomial is really when the factors are identical, and I can rewrite it as a perfect square. So why is it helpful to notice some of the things that exist in a perfect square trinomial? Well, it's really when your factors get quite large. So something like 25x squared plus 70x plus 49. Imagine doing this problem by grouping. 25 times 49. What? I don't want to multiply that. Let's check to see if this is a perfect square trinomial. And I know to try to check that because 25 is a perfect squared and 49 is also a perfect square. So let's see if I can derive these binomial factors by inspection. So 25, that's 5x times 5x. 49, that's 7 times 7. All right, so now we need to check, will my terms combine to make 70? I don't know. 5 times 5, 25x squared. 5 times 7, 35x. 7 times 5, another 35x, and 7 times 7, 49. Take a look. What is 35x plus 35x? 70x. So this works as an excellent backup strategy to grouping. And it's when you notice that your first and last term are perfect squares, and you're really just checking to see whether or not the expression is a perfect square binomial product.